How to understand Kirchhoff's laws. If you are curious about how to grasp Kirchhoff's laws, you are in the right place. These laws are essential tools in electrical engineering and circuit theory. They help us analyze and understand how currents and voltages behave in circuits. Let's break it down step by step. First, we have Kirchhoff's current law. This law tells us that at any node, which is a point where two or more circuit elements connect, the total current entering the node equals the total current leaving it. Imagine a busy intersection where cars enter and exit. The number of cars going in must match the number going out. In terms of current, we assign positive signs to currents entering the node and negative signs to those leaving. This way, when we add them up, they equal 0. This principle is based on the conservation of electric charge, and it applies to all types of circuits, whether they are linear or nonlinear. Next, let's look at Kirchhoff's voltage law. This law states that the sum of all voltages around any closed loop in a circuit is 0. Picture a circular racetrack. As you go around, the total energy gained from voltage sources must equal the energy lost through voltage drops. When you trace a loop, remember to pay attention to the direction of each voltage source and drop. Voltage rises should be counted as positive, while voltage drops are negative. This law is grounded in the conservation of energy principle and is applicable to any number of loops in a circuit. Now, how do we apply these laws in real-world circuit analysis? Start by identifying all nodes and loops in your circuit. Next, assign directions for currents in each branch. If your guessed direction is wrong, the calculated current will simply be negative. Apply Kirchhoff's current law at each node to create equations based on current conservation. Then, apply Kirchhoff's voltage law around each loop to from voltage equations. To relate voltages and currents for resistive elements, use Ohm's law, which states that voltage equals current multiplied by resistance. Once you have your equations set up, solve them to find unknown currents and voltages. Kirchhoff's laws are not just theoretical, they have practical applications. They are used to analyze complex resistor networks, design electrical circuits, and troubleshoot issues. They are also essential for understanding power distribution in both direct current and alternating current circuits. Remember some key terms. A node is where circuit elements connect, a branch is a path connecting to nodes, and a loop is a closed path in a circuit. Understanding Kirchhoff's laws involves recognizing their foundation in conservation principles and their practical use in circuit analysis. Mastering these laws will allow you to calculate currents and voltages accurately, which is vital for anyone working in electrical systems.